Good afternoon, Kunal.
Good afternoon, sir.
Yeah, we'll just start. Okay, I'm not waiting today for anybody. Yeah.
Okay, sir.
Uh, it's just give me a minute. I'll just message Priyanshu sir to see if I can take labs if one person is there. I wanted to take two labs. They're very easy. Even if you see the recordings, you'll understand. There's no problem about it. But
Okay,
just
sir.
in case, yeah, just give me a minute. Okay, three is good enough. Let's start. Is my screen visible?
Yes, sir.
Yes, sir.
Okay, thank you. Uh, have a new whiteboard. Okay. Let's finish unit 2. Okay, so the only part remaining is SNMP. SNMP stands for simple network management protocol. Okay, so what does it do? So this is basically a monitoring protocol. So sometimes in a network, okay, we have a network, there are PC servers, printers, routers and everything. Okay, and they need to be monitored. Okay, so they need to be monitored. Why they need to be monitored? They need to see how long they are up, what is the downtime, how much memory is used, CPU is used, what is the temperature, what is the name, the system files and so on. Why? So that everything is up. Okay, a recent what you say, the importance of this was when recently Microsoft was down. Do you remember? Which caused problems with airports and companies and stock market because the systems were down. Okay, so in order to not that happen, to make that not happen, avoid that, we use monitoring, and for monitoring we use SNMP protocol. Okay, so SNMP stands for, sorry, SNMP stands for what? Simple network management protocol. Simple network management protocol. Okay, so now imagine that there is a data warehouse. Okay, so you have this cloud house for example, and there are multiple servers in it. Okay, you have multiple servers. Now you need to monitor these servers. Why? You need to monitor the temperature, the memory usage, CPU usage and so on. Okay, so you are sitting here with your PC and this is connected to each server. So how do you monitor? You monitor using protocol SNMP. In this, there are two components. Okay, one is manager and one is agent. Okay, Yeah. So one is manager, one is agent. Now manager is used to what? To monitor and make changes, customization, basically administrator work. Okay. Some manager software that is on the PC is used to do what? Administrative work. Administrative work and monitoring. What does the agent do? The agent collects data. Okay. The agent collects data. Which data? The data from the server. Collects data from server. What does it collect? It collects multiple things. To name a few: name, system uptime, memory usage, CPU usage, temperature, and so on. Okay. Now, all of these, this is not exhaustive. Okay. There can be multiple. You can use your own custom also. We'll add one saying custom. Okay. Custom parameter. Now, all this is stored in something called as, now, sorry, all of these parameters have object ID. Okay. All these parameters are called objects and they have an ID called object ID. Okay. OID, which is object ID. Okay. So name will have an object ID like 1.3.6. 2.1. Then memory will have something like 3.6.1. CPU will have 1.2.1.3 and so on. Okay. So we have things to monitor. We have things to monitor. Each of those things have unique IDs. Okay. The things are called objects and their IDs are called OIDs. Okay. Their IDs are OIDs. All of this is then stored in a base or database, you can say, which is called MIB. MIB stands for Management Information Base. Okay. All these parameters, memory usage, CPU usage, temperature, system uptime, all these parameters with their unique IDs are stored in MIB. Okay. And this all is where? This is on the agent. This is all on agent. Where is the agent involved? Installed? It is installed on the server. Okay. It is installed on the server. And how do we monitor or manage it? Using manager software, which is on your PC. Okay. That is what the whole idea of SNMP is, to do all of this, to make sure that this entire process is run smoothly. We use protocol SNMP. This is what SNMP does. Okay. So the transfer of this information from here to there and monitoring and administrative work, customization is all done with the help of SNMP. Okay. Now, the reason why this OIDs, okay, they are called OIDs. Is OIDs seem like IP addresses is because this is of the tree structure. Okay. So MIBs are in tree structure or hierarchical structure. So what does it mean is that, for example, let's say there is a we want to monitor CPU usage. Okay. So this CPU parameter is in this MIB, okay, and it has an ID of 3.2.3. So what does this mean is there is MIB, okay, at the root level, okay. Then there are three parameters. Let's say uh, one is local, okay, which has ID 1. Then there is network, which has ID 2. And then there is programs, okay. There is a folder called programs, which has ID 3. In that program, there are two more folders. There is apps and there is x86, okay. In that x86, there are three parameters: out memory, RAM, and CPU. Out of which this is third, this is second, this is first. So CPU का ID कैसे आया? Like this: 3, this is 2 and 3. So CPU usage that you wanted to monitor has an ID of 3, 2, and 3. Understood? Okay, I'm gonna assume it did. Now, okay, manager and agent, I just told you what it is. MIB also I told you. You can go through the theory later. Okay. You have access to the recording, so you can pause the video over here and read it out. You can do the same for this, or else you can get it from the LMS portal. Okay. We have a plan to upload it today itself, everything, but if for some reason is missed out, you can go to the recording and pause the video and uh, check the theory. Next. So now there are certain messages that you uh, perform or use in order to work with SNMP. Okay, so you have your PC, right? And you need to monitor or you need to get some data. Okay, so one of the messages is get request. So you are on your manager software, okay, and on that software you said get request. For what? You will choose your OID parameter, which was in this case CPU usage, which was 3.2.3. Okay. And once you send the get request, that tell me how much CPU is used, the request will go to the host, the CPU, and you will get the information. Okay. For example, 59% is used. To give you a better understanding of the usage, let's say this is the uh, what do you say? This is the interface. Okay. This is the manager interface. Similar to FileZilla. Okay, I'll just show you FileZilla. Same like this. Okay, on the left side, you will have your MIBs. Okay, on the left side, there will be MIBs. What does the MIBs have? They have memory, CPU, system uptimes, etc. Okay, and here you will have how you have it over here. You have host, you have username, you have password, you have port. Same way you will have it here. Okay, you will have host, you will have password and port and etc. if there is any other information needed. I'm not sure what it is. Okay, after that you say connect. Okay, you say connect. Once you say connect, the message goes to the PC for which you want to monitor its CPU usage. Okay, so once it is connected, you send what? You send get request. What get request? 3.2.3, which is CPU usage for this. Okay, and then it sends back the message, and you will see it like how you see it over here, these files. That way you'll see it over here saying that CPU usage for PC is 59%, like this. Okay, there are multiple parameters and multiple things that you can monitor. So this is how it works: CPU usage, CPU temperature, CPU fault, CPU error, CPU message sending, CPU traffic, and it depends. You can even customize it. So the list is vast. Okay, that's what you can do. Let's go through a few messages. So these are so the most common ones or the most used messages or what you say requests of SNMP are SNMP's most common messages, requests, commands, whatever you want to call them, are get request, set request, and trap or inform. Okay. So get request is something like, let's say you say get name of the machine. Okay. And it returns you something like admin. So this is a get request. Or you can say set name to master. Now the admin name will be changed to master. And trap or inform is something that the agent sends you to inform something has happened. For example, if the PC that you were just monitoring uh, had an failed for something like memory failed or memory got full, for example. Okay, if its memory got full, if it is complete, it will send you the percentage. It will either send you a message that the memory is full, or it will send you a warning like memory usage is above 80% warning. Okay, this is what it will send you. So these three are the most common commands. There are others also, but these are the main ones. So get request, it is simply used to retrieve data from SNMP agents. In response, the SNMP agent responds with the requested value to a response message. Get next request, to get the value of a variable, the manager sends the agent get next request. The values of the entries in a table are retrieved using the kind of communication. The manager won't be able to access the values if it doesn't know the entries indices. This message is used to define an object in certain circumstances. Set request, I just told you. Response, when sent in response to the set message, it will contain the newly set value as confirmation to the value that has been set. Trap, these are message. Okay. Difference between trap and inform is that inform waits for the acknowledgement. Okay. Inform message waits for the acknowledgement, kind of like the stateful connection where the state is remembered. That way it waits for the acknowledgement, even though it works on UDP, it still is one that will make sure the changes have happened or the report is sent. So it does make sure that an acknowledgement is received. So trap, these are the messages sent by the agent without being requested by the manager. It is sent when a fault has occurred. Like I said, memory full fault has occurred, or the PC has failed, the PC has gone dead, battery is dead, something like that. Inform request, it was added to SNMP version 2 and it is used to determine if the manager has received the trap message or not. Like I said, an acknowledgement. It is same as trap, but as an acknowledgement. Yeah. All right. That concludes unit 2. We will start unit 3, but before that, okay. So our unit 3 is on virtualization, containerization, NAT, and I think that's all. But okay. Before we start unit 3, I wanted to take a few labs or what we would be doing in labs. They are extremely easy. I'll just show you a demo here and you have to do the same in Cisco Packet Tracer. Okay. So let's start. Our first is going to be this DNS. Okay. First lab will be first first lab will be DNS. Okay, DNS is taught, but in general, I will give you a okay. There are samples already when you download Cisco Packet Tracer. One of it is this one. So I'll show you how this DNS would work. Before that, let's initialize. Well, by initialize, I mean letting the, you know, ARP, spanning tree, and so on, all those other protocols to work. Okay, first fail and then on. Okay, now it's working. Anybody wants to explain how DNS works? Let's start with simulation. So I'm gonna go to https www.example.com. Okay, I say go and let's see what happens with the message. Please observe. Our experiment is going to be simpler than this, but the concept that I want you to, how do you say, remember is the one over here. Okay. Okay, DNS was not that. Never mind. It did not work as expected. Let's try again. Yeah, this is better. These are all DNS requests. You can see it over here. Type is DNS and DNS messages is going through the server and the router. Yeah, okay. Okay. So the DNS is finished. Now starts the TCP. Okay. Goes to the second router, third router, and to our website. The website replies back. Now starts HTTPS. Okay. Going through the same routers, switch to our server and back. Okay. Since you guys have attended or apparently seen, what happened? How was the process? What DNS process took place? So our first DNS message went from here, then it went to the server. Sorry, then it went to root DNS. Okay, if you see here, local DNS, then it went to root DNS. After root DNS, then it went to back to our client. From client, then it again, then TCP started. TCP went to server example. What was the logic over here? Why it went like that? And there is a previous step before it, but that is not taking place because the memory is cached. So I need to reset it completely. But as much as you saw, what was the logic? Okay, I am going to assume that you know, since nobody replied. Okay, and if you don't know, I would suggest go and see the recordings. Let's move on to the labs.
Sorry, Yash, just a minute. Hey
Yeah.
guys, are you attending the class regularly or not? I Are you guys there? Kuber, Kunal, Pratiksha, Momita, Digvijay.
Yes, sir.
Okay,
Yes, sir.
Yes, sir.
okay. Are you listening really? Please respond to the answers of the yes, sir. I was listening from last 5 minutes. It looks like no one is responding to him. So at least you should make the session interactive. Okay, don't be like turn on your listening mode and keep your mobile aside to table and all that thing. So that's why I request you or urge you to turn on your camera. That will be good if you are attending the class from home or something like this sessions. So it will be because it will give Yash also a positive because he knows everything. So if you respond to him, he will give his 100% of the delivery. Otherwise, I know if you are not giving the answers regularly or not making the interaction, so it will be like the guy who is delivering the lectures, he will deliver almost 70 to 80%. So it's urge from my side. If you are attending the sessions, please respond to the sessions. Okay. Now you're doing the MTech part. MTech is always be like doing the interaction and ask the teachers questions regularly. Okay. So now onwards, it's a request. Don't only like listening the classes, just do the interaction part also.
Okay, sir.
Okay.
Okay,
Thank
sir.
you. Thank you so much. Because next semester I'm going to take the class. So that's why I'm asking you guys to prepare now onwards. Like, don't be just listening more and always like that. At least you are doing if you are doing the MTech, then you have to do the interactions also. Not like, because I know Yash is doing his teaching from last 2 to 3 years, so he is very well on that. But still, if you are asked the questions, then only he will clear your doubts and everything. It's not like you are just listening the class, and so not only for the attendance, or just if you're paying that much, you should take care of like you should get some out of it. Okay, thank you. So do the interaction in the class. You go ahead, Yash, you can start.
All right. Thank you. Okay. Uh, let's start with the example. Okay. So this is more on the conceptual base of what happens on the higher level. What we are going to do is a little bit easier. Okay. Actually, a lot easier. So let's pick DNS. Okay. I told you make download this application and create your accounts. Okay. So in order to set up this scenario, what I did was I went into this is, by the way, on the opening page of your application. Once you are on this page, you'll find your devices over here. You can see network devices, you have end devices, components, wires, and so on. So you go on network devices and you select you go on end devices and you select your PC. Okay. You select your PC. You just drag and drop, and that comes up in the scenario. Okay. Next, I needed a switch. which again you can see on the network devices. You click on it and you pick up a switch. Now, most common is generally 2960, which I have picked up. Otherwise, there are different ones. Each has a different hardware and so different functionality. Okay, depends on what you want to do. If you are in doubt, obviously go to Google, or they have their documentation. Okay, you can get help. There are tutorials, or you can find the documentation of this on on Google. You can either find it on Cisco itself or the manufacturer of this switch 2960. Okay, all these are Cisco switches. Okay. uh, Sorry. So I selected a switch, and again, if you come on end devices, you have a server over here. I just drag and drop. That is how you get a server. Okay, I'm going to delete this, delete this. Okay, now these are labels. Okay, this is to select something. So this is a selection option, and this is the notes option. So you place a note, like for example, lab 1, which is DNS. Again, you go to selection and this goes off. So that's how I have written the labels. Okay, why I have written the labels, so that I know what this particular machine has and I don't have to continuously go and check. So this is one server which has the IP of 10.0.0.2. This is another server which has an IP of 10.0.0.1. I have configured this server to be a web server, and I have configured this server to be a DNS server. A web server is a server which will give you web pages. Okay. Facebook is situated on a web server that gives you the website of Facebook. Similarly, I have a web server which will give me the website https://yashraj.com. Okay. And we have a DNS server. Why? So that this site is accessible. Okay. Again, here we have the IP address. So now the first thing that I would do is configure the IP addresses for each of the devices. You double click and open, and then you have this physical. Okay. So these are the physical components of this. Similarly, like I said, you can have off switch also. See, you have modules, you have this switch. Okay. Zoom in, let's say this. Okay, you can, and this is clickable. There's supposed to be a, sorry, original size. This, since this is a switch, there is no power on off button. But if it was a router or something like that, then it would have a switch and it is clickable. Let's see if on the PC, this one, see, okay, this is clickable. I am not going to do so, but this is an interactive page. Okay, you have different modules that you can drag and drop. This Ethernet, you can get it from here. This you can get it from here. The microphone jack you can get, headphone jack you can get, as you can see here, it is at the bottom. So all these things you can drag and drop and place it on your system. Now, I wanted to configure the IP address. So what I'll do, I'll go to desktop, and the first option you see, IP configuration. You click on it, and this is the place where you enter your IP address. Since we are the ones who are going to manually set it, I have selected this as static. Okay, and I put the IPv4 address as 10.0.0.4. Okay, and the subnet mask 255.0.0.0. This subnet mask is calculated directly. Okay, so let's see, or rather, you know what, let's do it anew. Let's try to make a new file. Okay, so we have one PC, drag and drop. I have one, I need a switch. switches. I place the switch over here. Just a minute. Okay. You place your switch here. Now I need servers. So you go to these end devices, pick one server, pick another server. Okay. Let's put on labels. Let's pick this as 10.0.0.4. Let's pick this as 10.0.0.2. Let's pick this as 10.0.0.1. I go back to selection. Okay. This is my web server. So that's what I'll write over here. Web server. And then what I'm going to access on this web server, https yashraj.com. This I am going to configure as DNS server. Okay, let's make the connections. For connections, this is the option. This is for automatic connection. If you have a specific wire, you take it from here. So you have console, you have copper straight, you have copper crossover, fiber, phone, coaxial, serial DT, serial DCE, and so on. I'm just going to make automatic. Okay. And these automatics are done. Now, as I said, let's configure the IPs. Okay, you go to PC0, you go to desktop, IP configuration. As you see, this is blank. Okay, and static. Why? Because I am going to manually enter the IP address. So 10.0.0.4. Click anywhere in the grayed out part. Subnet mask is calculated automatically. Let's do the same for web server, desktop, IP configuration, 10.0.0.1, automatically calculated. Same for this server. Done. Okay, so now our IP addresses have been configured. If you want to check, you go to command prompt. Let's try pinging 10.0.0.1. See, it's pingable. That means you can reach the web server. Now let's ping the DNS and see if it is reachable. Okay, our DNS server is reachable as well. We are sending 4 packets and we are receiving all the 4 packets. You can see over here. Okay, good. Now let's configure our web server. So you select this, you go on services, okay, and then you go on HTTP. Okay, why? Because we are going to make it a web server. HTTP is on, HTTPS is on. Now, for any website, the default page is index.html. Okay. The default page for all websites is index.html. Let's edit it. We don't need any of these things. So slash header, let's say hi class. Welcome to lab 1 DNS. Okay. Let's make it. End the tag and we are good to go. File manager. Okay. Now we have created a web server. Let's see if we can access it. HTTPS www.yashraj.com. It says host name unresolved. Why? Also, do you remember I told you that we use something for hostname unresolved? We get this messages here, reporting messages, destination unreachable, host unresolved. This is what? This is a type of ICMP v4 message reporting that host is unreachable. This is under this category. This is how it comes. Okay. So a good example of what has happened. Yeah. So why now my web server is there and I'm trying to reach https yashraj.com. Why is the website not coming? Why is the host unreachable? But I mean, we had pinged the machine, right? But it is still unreachable. Why so? See, we had pinged it. We got the messages, but the website is not coming up. Why? Okay, since we have less time, because we have not configured the DNS. Okay, since DNS is not configured, the host is reachable, but the website is not accessible. Okay, I hope you get this point. Because the DNS record is not configured, the web server is reachable, but the website is not accessible, or the host is unreachable. Error you get when you do https://yashraj.com. Okay. Now DNS. DNS stands for domain name server. What does it do? Forget the working. Just tell me what does it do? What is its one job, one functionality? Wow, so much attendance on a Sunday. Yeah, what does DNS do? One functionality. Come on. Okay, you find it on your own. So now we make a DNS change. We configure DNS. We again go into services and we go into DNS. What change we will make here? We will put name for what we put name. I put the name of my website. Okay, and I put the address of the web server on which the website is there. Okay, it's on this server. I put add, it gets added, and DNS service, I switch it on. Okay. Now, let's see if it works. Okay. Again, PC0. We go to programming, sorry, desktop and HTTP browser. Let's try to reach the website again. HTTPS yashraj.com. Go. Hostname unresolved. Okay, let's try with this. Okay, let's see what the problem is. Service on yashraj.com. Let's try www.yashraj.com. Okay. Yeah, we need a record. Let me check what is missing. Just give me a minute. All right. So yeah, so now our DNS has a record of what do you say? Our DNS service has a record of my website or the web server, but my PC does not have it. Okay, so the change that needs to be done is in PC. Okay, my PC needs to know where this web server is so that he can reach the web server and access the website. Who knows where this web server and this website is? DNS server knows it. Okay, DNS server knows where my website is on which server, and my PC needs to reach this server. As you can see, if you go in IP configuration, DNS server is set to 0000. But is that the case? No. DNS server is 10.0.0.2. So I will make a change here, 10.0.0.2, so that my PC goes from my PC request goes to DNS server asking, hey, where is the website https://.com. DNS servers tells my PC that this website that you're looking for is at 10.0.0.1. Then my PC sends a TCP request and HTTP request to get the website yashrash.com, as you saw in the example that I showed you before. That is the default example that you will get when you download this application. Okay, that one is by default. This is what we are creating. Now hopefully this works, everything is correct, and we go to HTTP browser. Here let's type again https yashraj.com, sorry, www.yashraj.com. Yeah, there it is. Okay. Hi class, welcome to lab 1 DNS. So we have finally reached our website, and this is how you can access any website. This is how websites are designed on the internet, and you have got not only the accessibility of the host but also of the website that is hosted on this web server. Okay, next, if I give you another example, let's add another PC. Okay, make a connection. Okay, let's open PC1. Now if okay, I haven't put IP address for this, so let's put on the IP address 10.0. I think we are done with 1 2 4. Let's put this as 3. I have just put a label. Now time to configure. Open this up, PC1, go to desktop, you see IP configuration. It is static because I am manually entering the IP, and you put 03. You click anywhere, you get the subnet mask. Okay, that's done. Let's open PC0. Okay, and let's ping 10.0.0.3. It is pingable, right? I can reach the host. But what if I do ping PC1? Why PC1? It is its name. You can see over here. The name of this PC is PC1. The name of this PC is PC0. So if I do ping PC1, request is not completed. So why does it happen that for IP address it is pingable, but for name it is not? The machine has not changed, the connection has not changed. But if I ping the IP address, it is connecting, I'm getting a reply, but if it is a name, I am not. Okay. Again, I don't think anybody is going to say. So I'll tell you again, the reason is because there is no DNS record. Okay. Because it lacks a DNS record, this PC is pingable only from the IP address and not from the name. So let's make the change over here. Again, we go to its DNS service and we add the name. What is the name? PC1. What is the address? 10.0.0.3. Okay. Say add and it is automatically saved. Now let's try again. Save. Okay, let's try say ping PC1 and it works. Okay. Now the PC1 is pingable from the IP address. Okay. As well as from the name. Okay. So now your PC is pingable by both. Okay, that concludes your lab 1. Okay, let me see if I should save this. Okay, let's save. Okay. Next we have DHCP. Okay. DHCP stands for Dynamic Host Configuration Protocol. Okay. What does it mean?
Sir, it automatically gives the IP addresses.
Correct. Right. That's it. This is the easiest lab, easier than the previous one. There is another previous one where you don't even have to do anything, but let's see how this works. Okay. It cannot get easier. Sorry. So I have a server and a few PCs connected to it via switch. Okay. Let's try to replicate it. I'll go to new. Yes. Again, same thing. You go to network devices and end devices. Sorry. You take a PC. Let's take a laptop, a server. Okay. And let's take a printer. Okay. Let's take a switch. I think switch is over here. Yeah. Let's take the common switch and make automatic connections. Okay. So this is our connection 1, connection 2, connection to the server, and printer to this. Let's add a IP 10.0.0.1/8/8 is for the subnet or the network which it falls under. Okay. Now first we configure, nothing is set, as you can see, not set is there everywhere. So you click on the server, you go in the desktop, IP configuration, and manually set up the IP address. Okay. .0.0.1. You have a subnet mask automatically calculated. Okay. Then you go to services and you go to DHCP. Why? Because we are going to configure the DHCP server. We are going to make it a DHCP server. So we put the default gateway, which would be 10.0.0.1. and we put the service dot 0 and we put the service as on. Okay, I think if you put 1, that wouldn't still matter. Yeah, because this is the start and end address. Max users, you can change on your own. DNS server, we don't need it because we don't have it. We are not reaching anywhere else. Okay, our DHCP server is configured. Now let's see if this works. We open PC0. Okay, we go to desktop, IP configuration, and click on DHCP. See, you saw requesting the address, DHCP request successful, and you have got a IP address automatically. Let's do the same for this laptop. Go to desktop, IP configuration, DHCP, requesting IP address, and there you have it, an automatically configured IP address 10.0.0.3. Mask is automatically calculated. Let's do for printer. I hope you know that printers also have their DHCPs, IP addresses 10.0.0.4. Okay, even your printers, if there was a smart TV, it would also have a IP address. Okay, for you to experiment, choose this VoIP device, voice over IP device, and see if this one gets a IP address. You can check for TV and tablet as well. See if these guys get an IP address when you connect them to the DHCP server. Okay, lab 2 is also done. Sorry, this is for message. Let's see, lab 2. Okay, lab 2 is done as well. So lab 1 and lab 2 are completed. It is, yes, as showed you, simple and takes maximum 10 to 15 minutes to complete. Okay. No, I don't want to save. Let's go. Let's get to our next unit, which is virtualization. Okay. Let's take 5 minutes break and we will continue. Okay. I think it is still 4:15. Yeah. Okay. Let's meet back at in 10 minutes. Let's meet at 3:40. Let's take a break. Hello. I'm assuming you guys are there. Let's start.
Yes, sir.
Great. Okay. Let's start with virtualization. So if does anybody already have an idea of virtualization? I'm sure somewhere you must have done something regarding it. Really? Not even heard of it?
Sir, heard of it, but not done anything like
Okay.
practicals or like that.
ठीक है. Okay. Practical तो ऐसे भी not much that we can do on this level, and neither technically most of it is like already done. पहले ही होके आता है, not something that we need to look out for a lot, like we do in, for example, like this subject of us in networking or infrastructure or coding otherwise. Okay, let's more of theoretical subject. Okay, let's start. So okay, so this whole idea came up because okay, because it was, let's say you have a company. Okay, so you have your own company and you need multiple devices. Okay, before virtualization, what it used to happen that we all everybody used to have their own PCs and servers and everything. So it was very expensive and hard for a company to cope up with. Okay, you needed to have one server for emails. Okay, then there is one server for web server, like we just had with the one server for DNS DHCP, like you just saw. Then there is another server for database, another server to hold like GitHub, for example. Okay, so as you see this is 1, 2, 3, 4, 5 servers. Okay, servers are expensive. If a PC is coming for 1 lakh rupees, server will at least be thrice or more than that. Okay, so it becomes pricey. Okay? Along with it, you also had to buy PCs and all that stuff. Now, in order to overcome this hurdle, okay, please mind you that money was a big factor, but there were other factors like utilization of the server, the power, the ability, the scalability, the flexibility. All these factors led to the invention of virtualization. But I would say the major one was the money. Okay. Now what happens is that because of virtualization, I don't need these many servers. Okay, all I need is one server. Okay, I have one server, that's it. And in this server I have my hardware, I have my OS, and then I have my different virtualized servers. Okay, so here there is server 1 which is used for email, server 2 which is used for database, server 3 which is used for whatever, web server. So as you can see, now we reduced the number of servers required to just one, and the functionality that we needed is virtualized. Okay, instead of needing different servers for email, okay, email, web server, and database, we combined it all into one server and virtualize the functionality. This is what is known as virtualization in an existing hardware to bring in multiple functionalities. Okay. Okay. According to IBM, virtualization enables the hardware resources of a single computer, processes, memory, storage, and more to be divided into multiple virtual computers called virtual machines. Okay. In another point to note is that you can also run different um, this different OSs on this servers. Okay, so for example, let's say your main server is something else. Let's not focus on that. You have virtualized everything else. Okay, so you have virtualized your email and you are using the OS as Windows. Okay, you have database, the OS is Linux, and you have a web server for which the OS is Unix. Okay, this is very much possible because of virtualization. Otherwise, you would, without virtualization, how does this scenario go? You have one server, two servers, and three servers on three different operating systems and different functionalities, right? You have this for email, DB, and what was the last one? Web server. Okay. Virtualization. In simple terms, virtualization is a technology that can transform hardware into software. Today, virtualization is a standard practice in enterprise IT architecture. It is also the technology that drives cloud computing economics. Virtualization enables cloud providers to serve users with the existing physical computer hardware. It enables cloud users to purchase only the computing resources they need when they need it, and to scale those resources cost effectively as their workloads grow. The VMs work in isolation, they do not talk to each other. Okay, so these servers that you just saw, different ones on one server, they will be isolated and will not talk to each other. By talk to each other in the sense that they will not communicate with each other. Okay, so for example, if email server fails or goes down, it is not going to affect the database server or the web server because it is isolated and virtualized. Okay. Yeah. Benefits of virtualization: resource efficiency. IT preferred one application and one operating system per computer for reliability reasons. Invariably, each physical server would be underused. In contrast, server virtualization lets you run several applications, each on its own VM and its own OS on a single physical computer, typically an x86 server, without sacrificing reliability. This enables maximum utilization of the physical hardware's computing capacity. Okay, a task for you is to understand why servers are not used to their full capacity, and why. Okay, and why we basically introduced virtualization. And because of virtualization, okay, because of virtualization, the ability to use more capacity of the server was introduced or increased. Okay, search this question for yourself. Easier management. Replacing physical computers with software defined VMs makes it easier to use and manage policies written in software. This allows you to create automated IT service management workflows, example bulk VM creation, updating, etc. Okay, the whole point of this, another what do you say, the whole goal of this virtualization was also to make sure that scalability is possible. Now imagine in the previous scenario where you had three servers. What if your email server dies out? okay, or it fails, you have to buy a completely new one. Okay, so the space is wasted, money is wasted, or the basically the resource is wasted. But in virtualization, what happens is it is easier to manage. You don't have to buy a new um, hardware. Okay, you don't have to buy new hardware. You just have to reset and replace, clean the software. Okay, since it is a virtual machine, so you already have a server, right? You already have a server. It is, you have virtualized email on it, you have web server, and you have DB. So now in this case, in virtualized, if email goes down, the only thing you need to do is create a new one, right? Okay, clean this up, format it, create a new VM, and then add it back again to the server. Okay, that's how your efficiency is increased. Again, you have on the same hardware, you have VB, which is undisturbed because it was isolated. If you remember, isolated, so undisturbed, database is there, and our new VM formatted one goes to the failed slot. Okay, so that is the efficiency of virtualization. Another thing is that if files are deleted or some memory gets corrupted, it does not affect because all the files are stored on virtual files. Virtual files in the sense where it will be stored, it will be stored in data center. What is the data center in this case? It is the cloud. What are the cloud examples? Google Cloud, AWS, etc. Yeah, bulk creation also. Okay, another point is example bulk VM creation, updating, etc. So another point was, if I want to say, let's say tomorrow I have a requirement of 100 servers, okay, to fulfill the email demand and the web server demand. Okay, the people, the traffic coming to my website has crossed 1 lakh requests per day. Okay, and my server currently holds only 1,000 requests per day. Okay? So it's very inefficient to go and buy 100 servers, right? You cannot get it in a day. You cannot afford it also because they are very expensive. Plus the entire capacity of the server is not used. So what we do, that is why we have VMs. Okay, VM stands for virtual machine. If I have not mentioned it before, mentioning it now, VM stands for virtual machine. We have VMs. So the great thing about them is that they are inexpensive and they are highly scalable and flexible. Okay. So now if I want to fulfill my, sorry, now if I want to fulfill my 1 lakh request, all I have to do is create my, all I have to do is create VMs in bulk. Okay, which I can do anywhere remotely. I can do this remotely. Okay, I can create 100,000 whatever VMs in order to fulfill my 1 lakh requests. So by the time, or in few hours, by tomorrow, I can create multiple virtual machines which will fulfill the requests. Okay, so that's why this is one of the benefits of virtualization, bulk creation. Minimal downtime. OS and application crashes can cause downtime and disrupt user productivity. Admins can run multiple redundant virtual machines alongside each other and fail over between them when problems arise. Faster provision. Buying, installing, and configuring hardware for each application is time consuming. This point is what I explained just now. Okay. Provided that the hardware is already in place, provisioning virtual machines to run all your applications is significantly faster. You can even automate it using management software and build it into existing workflows. Again, examples are clouds, Amazon AWS, Google Cloud, Microsoft Cloud, which is Azure. If you have experience, well and good. If you don't, you can go on these websites and see how easy it is to create multiple VMs and what it means by faster provisioning, why it is easier to, instead of buying, installing, we just virtualize it. Okay. If you don't want to go cloud wise, you can go particular company wise, what do you say, application wise, and one of those applications is VMware. I'm sure you must have heard of VMware.
Yes, sir.
Good, that's great. Okay, now hypervisor. A hypervisor is the software layer that coordinates VMs. It serves as an interface between the VM and the underlying physical hardware, ensuring that each has access to the physical resources it needs to execute. It also ensures that VMs do not interfere with each other by impinging on each other's memory space or compute cycles. समझा इसमें से कुछ? Okay. So hypervisors are nothing but operating systems for virtual machines. जैसे माइक्रोसॉफ्ट का विंडोज है, वैसे उसका एक और ओएस आता है फॉर वर्चुअल मशीन्स कॉल्ड हाइपर वी. VMware माइक्रोसॉफ्ट का ये है. VMware करके कंपनी है, उसका ओएस आता है कॉल्ड ESXi. Okay, these are operating systems for virtual machines. Now, another thing that they have noted is it serves as an interface between VM and underlying physical hardware, ensuring that each has access to the physical resources it needs to execute. अब virtual machine इसका मतलब ये नहीं है कि it can go beyond your physical hardware. अगर मेरे एक सर्वर है, उसके पास रैम है 100 GB, ठीक है, एंड उसका स्पीड है, ट्रांसफर स्पीड है 5 gigabytes per second. The virtualization that you create cannot go beyond these hardware specs. हार्डवेयर स्पेक्स के बाहर जा नहीं सकता. Okay, so to give you an example, okay, I have this server, this main server, ठीक है. This main server has memory of, sorry, this has a memory of 100 GB, not RAM, ROM. Okay, speed of 5 gigabits per second, and let's say it has 12 CPUs. Okay, now I want to virtualize this so that I can have an email server, web server, and a database server. Okay, I go here. Let's create those. This is my email server, my web server, and my database server. Now, I want to create these servers with these given hardware specs. These hardware specs are not going to change. Okay, so I need to virtualize this one server into these 3 servers and distribute this power. This is what it is written here. It needs to execute also ensures that do not interfere with each other, impinging on each other's memory space or cycles. Okay. So who does this? Hypervisor. My OS hypervisor will help me to this hypervisor helps me to virtualize my original server. Okay. Now, okay. So, can I have 3, 4, and 7 CPUs distributed like this?
No, sir.
Okay, why not?
Sir, it's beyond the capacity of the main server.
Great, good. Okay, so I cannot have it. I can have 3, 4, 7, and the remaining 5 over here. Okay, I can change however I like, but I cannot go beyond 12. Same way for memory. I can have 33, 34, 33 GBs. Okay, and speed. Okay, I can have, let's say, can I have all as 5? Can all my servers have a transfer speed of 5 gigabytes per second?
No, sir.
Why not?
Sir, because they are not connected to each other. Like they means isolation में काम करते हैं ना वो तो फिर.
Mm-hmm. Okay, but the thing is isolation में काम करते हैं, it means that they don't, like memory के लिए ठीक है. Okay, I cannot take this memory allocated. Okay, my suppose ये memory slot है. Okay, this is the memory slot. Okay, so the first 33 is given to email. Okay, next 33, next 34 is given to the web. This memory won't be crossed, but 5 GB per second is the speed, transfer speed, which is independent of anything. वो तो PC का ये है, or what do you say, is the capacity of the server. So while transferring anything from anywhere, like assume तुमने USB लगा ली, ठीक है, तुम अगर USB की कैपेसिटी 100 GB हो, 5 GB हो, कुछ भी हो, ये स्पीड तो चेंज नहीं होने वाला ना, राइट? The slot memory can, I cannot go beyond 100, I cannot go beyond 5 GB, but I can distribute the same to all. Getting my point?
Yes, sir.
Because this is not, it's not like a wire. अगर ये होता कि 5 मीटर होती, let's say 5 मीटर की वायर होती, तो फिर ऐसे होता कि एक यहाँ, 2 यहाँ and 2 यहाँ, because 1 plus 2 plus 2 is equal to 5. Now it cannot go beyond 5. But this is not about the length or the physical attribute. This is about the speed, which is virtual itself. 5 GB per second is the speed that the server has. So I can make 5 GB for all because there is no physical thing to distribute. Okay, it's like what do you say? Like some one of those maths problems जिसमें if you add number of people तो काम कम होगा कि नहीं, ऐसा नहीं है. अगर एक इंसान 10 मिनट लेता है तो सभी उस, sorry, if it takes 10 minutes to finish that work, a particular work, no matter how many you add, it will still be finished in 10 क्या कहते हैं, minutes. Okay, that's the thing. For example, अगर तुम्हें गेम डाउनलोड करना होगा, ठीक है, अगर तुम्हारे इंटरनेट स्पीड 5 GB per second है, will it matter if you add more CPU, more memory or more GPU? It won't, right? Because Wi-Fi इंटरनेट का स्पीड ही 5 GB per second है, तुम उसके बियॉन्ड नहीं जा सकते. So the same way, I cannot go beyond the speed, but I can definitely give this speed to each and everyone. Okay, understood?
Yes, sir.
Great. Okay, last topic for today. There are two types of hypervisors, type 1 or bare metal hypervisors, type 2 hypervisors. Type 1 or bare metal hypervisors interact with the underlying physical resources, replacing the traditional operating system altogether. They most commonly appear in virtual server scenarios. Type 2 run as an application on the existing OS, most commonly used on endpoint devices to run alternative operating systems. They carry a performance overhead because they must use the host OS to access and coordinate the underlying hardware resources. And to show you an example, type 1 hypervisor. इसमें कैसा है? So this is your bare metal. Okay, this is your bare metal microchip or motherboard. इस पे क्या रहेगा? You have CPU, okay, you have pins, then you have memory slots, okay, a few capacitors वगैरह जैसे दिखता है, okay, the golden pins over here, then you have connections, okay, you have connections like this and everything. This is bare metal. ठीक है, इसके ऊपर लगता है तुम्हारा hypervisor, and this hypervisor gets you VMs. This is VM1. ठीक है, this is VM1, this is VM2, sorry, and this is VM3. Here you have Windows and email server. Here you have Linux and database server. Here you have Unix and web server. Okay, this is type 1. This kind of hypervisor OS is called type 1, which is directly on the bare metal. Then there is, and this is mostly used in servers. Mostly used in servers. Now you have the second type. Okay, type 2 hypervisors. Mostly used in PCs, desktops. जो अभी तुम्हारा है उसमें कैसे है? You have bare metal, the one I showed you above. Okay, bare metal के ऊपर होगा तुम्हारा OS. In this case, my laptop that I'm using, what I'm teaching you is Windows. Okay, उसके ऊपर आएगा एक और OS, which is the hypervisor used for VMs. Example is VMware का ESXi. So you have desktop ka OS. Okay, you have desktop OS, you have virtual machine hypervisor VMs ka OS, and then you have again your VMs, VM1, VM2, and VM3. Again, same thing. You have emails, web server, database. You have again Windows over here, Linux over here, and Unix. Okay, so your first desktop, you have bare metal. Okay, you type 2 में कैसे होता है? You have bare metal over here, उसके ऊपर डेस्कटॉप वाला OS Windows, उसके ऊपर VM वाला OS For example, VMware का ESXi from the company VMware. VMware is the name of the company. And उसके ऊपर you have virtual machines. Okay. These are the two types of hypervisor. To show you an example, this is a hypervisor of vSphere. vSphere is a hypervisor. जैसे VMware का ESXi है, वैसे vSphere भी है. Okay, this is how the what do you say, OS will look like. Okay, we have hypervisor, V virtual machine 1, 2, then you have manufacturers, VMware का vSphere, sorry. Okay, you can define kitne processors chahiye, virtual machines, the cores, okay, CPU cores, usage, etc. so on. ठीक है, this is how a hypervisor looks. ठीक है, इस पे तुम सारे सेटिंग्स करके एक VM क्रिएट कर सकते हो या फिर मैनेज कर सकते हो. ठीक है, if you check, it is home, inventory and this, so you have two virtual machines. This is just an example of how it looks. It will look different for different hypervisors. Since I don't have a hypervisor to show, I'm showing you a photo. And hopefully that will help. Otherwise, you can Google or go on YouTube. Okay, this is for next time. That's it for today. Thank you so much.
Thank you, sir.
Thank you, sir.